look at an example, a familiar example whereby we have a light bulb that is 25-watt light bulb. Now the question is, if the voltage across a 25-watt light bulb is 120 volt, so what then is the resistance? Now what you have here is basically you have P is equal to 25 watt, and also you have V is equal to 120 volt. So the third thing which is unknown here is the resistance. So you look at all these equations here, you pick the one with the known P and V, and then you need to find it out, and obviously you'll be using this equation, and therefore 25 watt is equal to V squared, which is 120 volt square divided by R, and therefore R is equal to 25 divided by 120 square, and that's known. That quantity is fairly small. Okay, it should be the other way around, which is 120 square divided by 25. This a correction here. So what you have here is 120 square is 144.00 divided by 25, and if you multiply that by 4, multiply that by 4, that's 100, cancel out the 2 zeros, so that is equal to 576 ohm. So that's the answer to the question, that the resistor has a resistance of 576 ohm. So the second question that we can ask is, what then is the current flowing through the 25 watt light bulb? Now that we know both the V, the resistance, and we also know the voltage, then you can derive that by V equal to IR, so I then would be equal to V divided by R equal to 120 volt divided by 576 ohm, and that's give you less than 1 ampere. Obviously, you can also take this relationship where P, which is 25 watt, and also you have a voltage, you can directly, easier would be to calculate I, and therefore from this equation here, I would be equal to 25 watt divided by 120 volt, and that's a lot easier to calculate that. Basically, you get the answer that much more directly. Now, I give you a thought question here, is that when I measure the resistance of a 25 ohm light bulb, I got a value of only 40 ohm. What is wrong here? Well, according to our calculation, we have 576 ohm, but when I take a light bulb and literally measure the resistance, it's only 40 ohm. What's wrong here is basically you're measuring the resistance when the light bulb is cold. So when the light bulb is cold, the resistance actually turn out to be less. When I'm talking about a 25 watt light bulb, it is when the light bulb, the filament is heated up. So apparently, the answer to that question is that the resistance of the wire increases as the temperature increases. For tungsten, the temperature coefficient of resistivity is 4.5 times 10 to the minus 3 increase in resistance per degree Kelvin. So a light bulb operating at 5,000 degree Fahrenheit would have a resistance that increased more than 10 times from 40 ohm to 576 ohm. So we need to look at when we specify these power and also the resistance and the condition whereby you do the measurement, whether the light bulb is a cold light bulb or a very hot light bulb, make all the difference for the actual value of the resistance. Now, let me just explain a little bit more. The question is, why is resistance increasing with temperature. And again, you have to explain that in terms of the kinetic theory of matter. So again, the electron that we had earlier, now that is moving down at the same voltage. And what you have here is that even the voltage is the same, is moving down like that, but when the temperature of the conductor increases, what happens, these atoms are far more agitated. So the agitation, actually, when you have the electron hitting on on an atom, the agitation will cause the electron to bounce back tremendously because the energy of the atom is high, and the electron hitting it actually has a recoil that is far good, bouncing it far back, and therefore it causes the motion of the electron so much more difficult to pass from one end of the conductor to the other end. And that's a physical explanation of why resistance increases with temperature. So when we talk about resistance, we talk about if in case you have an open circuit, if I take away the resistor, and this is open, obviously the current is equal to 0. And if you look at V equal to IR, I is equal to 0, V is a constant, then the resistance actually is in fact infinite. So an open circuit corresponds to an infinite resistance. And if you talk about a short circuit whereby you remove the resistor, replacing it instead with a wire of zero resistance, obviously the resistance is equal to 0.